Greetings, this is Artie from Artifact Electronics. I recently picked up this beauty. It's an HP model 54200A digital scope made in the late 80s. And I picked this up at the local university salvage and I got it for $40. Of course they charge you tax on top of the $40. Which is kind of strange because this is a publicly funded higher educational institution, and when you buy their old stuff they still charge you tax, so go figure. But anyway, you know, so for under $45 this thing came into my possession. It's in really good shape actually. I would say it was really well taken care of, sitting in somebody's lab and collecting dust. And one of the weird things was that when I found this, on the shelf right next to it was a LaCroix 9400 scope. And the 9400, you may remember, I did a previous episode on, which I failed miserably in my repair attempt. I got the screen back up on it, but I couldn't get channel 2 to work properly, and I finally blamed it on a bad ASIC and left it at that. So it seemed like a really strange coincidence that that same scope should be sitting there for the same price as this one. And I was tempted to take the LaCroix. I brought it to their little test bench, and it powered up, but the screen didn't light up. And I knew I could fix that, but I didn't want to go through that again. So I brought up this guy, I plugged him in the test bench, and he came up. Well, the screen came up. They don't have any BNC cables or anything like that there, so you're basically doing a power on test and see if the screen's readable. And looked good enough to me, so I took it. It did come with the full manual here, and you know, it says service manual, it's original, it's fantastic. I thought, well, with a service manual, who can go wrong? But of course I didn't check it in depth, and when I brought it home I noticed that the service manual had schematics, but only for the power supply. None of the other boards were represented in the schematics. There weren't even block diagrams for each of the boards inside. It just kind of told me what they were and left it at that. So let's power her up and see how well she does. There was one thing missing, and that was the button, or the key top for the power switch was missing. So you had to stick a pen or something in there to get it to start. And the way I fixed that is I cut a short piece of an ice cream stick, about 1 inch long, that's hollow inside, and just so happens to be the right diameter to fit over the stub inside, and put that in so I don't have to stick my finger, pens, or any other implements into this cavity to get it started. So to start it up, gives us 2 beeps. And it's really explained nowhere what those 2 mean, but it comes up. Now, the screen on this, well, I'm looking at it, it's really gorgeous. It's nice, it's sharp and everything. But the CCD in the camera is getting oversaturated. I can see that in the video. It can barely, if at all, read what's on the screen. So, when I did the TRS-80 in the last episode, all I had to do was turn down the brightness or intensity, and it became much better readable on video. So why not do the same here? And that brings us, of course, to the next issue, and that is, look at the user interface on this thing. Got a few buttons. There are no rotary controls whatsoever. There are no switches. There are no shortcut switches, for instance, for setting the channel mode between AC and DC or anything like that. Now, most of those functions are available, but you got to do some menu diving to get to them. But as far as the intensity is concerned, Nothing hidden under here, no buttons to twiddle, nothing. I can't turn down the intensity so you can see this better because there's nothing apparent on the front of the instrument. I did go through some of the menus, and there's nothing you can do from the menus either. You got to open this thing up, and there's a pot back here somewhere. It's probably leading straight to the flyback, and that's the only thing you can use to adjust the intensity and also the focus. So what I'm getting at is, I guess this was an attempt by HP to make the scope more user-friendly, even though I totally do not agree with that. The user interface is very awkward at best. Even though I read up on the scope, and some people claim that HP tried to force you to use HPIB remote commands on this, that should really be the way to use this properly. But even if you remote into it, you still can't adjust the screen intensity. So it takes some getting used to this user interface, but I still haven't gotten used to it. Now remember, I plugged it in there, it looked like this, everything looked fine, but there is one thing that I did miss. So let's display something. I got this BNC cable plugged into the back. It's got a test output that'll give you some really convenient signals, such as permanently low, permanently high, but there is a 2 kHz test signal in there. So let's plug that in, and it actually caught it, and we see a beautifully overshooting square wave here. And let's measure it. It's supposed to be 2 kHz. So let's see, if we go shift frequency, and then we got to tell it channel 1, and it tells us 2 kilohertz. So that kind of works. And the way it works is when you put an arbitrary signal into here, there's no dials to turn. You can't change the amplitude, you can't change the time base, not from the front, not directly. You can go into menus and do that, which makes it really inconvenient. But you know, this one came up, so let's go and put the square wave to the second channel. And the button that will help you, that is going to be your best friend, is called auto scale. So when putting in an arbitrary signal, you need to press auto scale. You can hear some relays click, and in this case you will see that channel 2 isn't doing anything. So let's check. I mean, the frequency, the cursor is still on the channel number that you want to see the frequency for. So if we change that to 2, and then it says scaling. But the bottom line is, it's not displaying anything. And it also swapped. It put channel 1 down here and channel 2 up here. I'm going to have to keep giving you explanations because I'm assuming that it's too hard for you to read what these say. But all we're getting is a slightly noisy line over here. And I mean, it booted up, it gave me 2 beeps, which normally mean everything is fine, but obviously they are not. So let's go. There are some self-tests here, and we can execute test number 0, which tests the CPU and memory. So you select the test you want, and it passes the control test, ROM test, and RAM test. Fantastic. Now we go and do test number 1, which is the acquisition trigger test. Disconnect all signals and press insert. So it's not enough that they have this weird UI, they don't even have an enter key. You have to use the insert key. So let's insert the test, and passed 100 megahertz clock, passed auto scale test, and interpolator test, channel 1 test, and failed channel 2 test. I also passed the external trigger test. So it's internally generating the signals to test it, but lo and behold, channel 2 fails. So the only thing remaining is our input test, and that is number 2. So connect rear panel BNC to channel 1 and then press enter. So now it's actually going to generate the signals it needs. Did I say press enter? Press insert. So pass channel 1 test, and now put the BNC into channel 2. Failed channel 2 test. So it doesn't work in this mode either. And finally, BNC into the trigger input, and it passed the external trigger test, but it gives us a general error on test 2 because it failed the channel 2 test. So what we're going to have to do is take this thing apart and use a lot of guesswork and reasoning here to see if we can trace what could possibly be causing this. Took off a few panels from the back, which I had to take off to get the top cover off, and at first glance it looks just like an HP. See a bunch of boards plugged into it, and beautiful workmanship as we've come to expect from HP. And here in the back you can see the controls for brightness and focus, which are in fact connected to the flyback, which you can see to the left, and there are some other manual adjustments in here. And again, we should probably go in and measure the power supply voltages. Caps look good, but there is, as I mentioned earlier, there are full schematics for the power supply in there, so if we get lucky we'll find a problem here, even though I will make the prediction that it's not the power supply, because if it was the power supply we'd probably be seeing similar problems on both channels. And yes, it could be, if the power supply is marginal, that one channel just is right on the edge and works, and the other one's right below the edge and fails. But let's have a look and see what these voltages look like. They're actually labeled underneath this connector, and let's set it up so we can measure those. Okay, let's measure the supply now. Let's plug in the device. Now you're supposed to let this heat up for a few years before getting good readings, but I'll usually go in and measure things right off the bat. I like to catch these errors while they're still fresh. Now let's see, we have so the first one is ground. The second one is plus 15. Then we have plus 12. Plus 5. Minus 2.4. Minus 5. A little low. Well, a little high in magnitude, but a little low. And minus 12. And another ground. So let's do the obligatory AC check. That one's good. 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 So the power supply looks good, and they do have some helpful LEDs on there, right over there, that indicate different faults. But the LED that's lit says, what does that say? I can't even read it from here, but that LED means that everything is correct on the power supply. So the power supply passes, and now we need to enter the great unknown and manually try to figure out what's going on here. Turn it around and remove the bottom cover, bunch of shields, and here is the bottom board with the components facing away from the cabinet, and this is the so-called analog board. And again, this is really the only board that I can test live, because the other boards back over there all face downward, and I don't have extender cards for this, so I cannot test them live. I can't even test this one, because in order to run it I have to reinsert this board, which fits on top of this, so that nicely takes away any access to this board. So my only chance of doing some live measurements are with this board over here. Now, there's no block diagram, so there's going to be a lot of guessing going on here, even though some of it is obvious. But we got our three inputs over here, channel 1, channel 2, and the trigger. There are two relays per channel. There's one bigger relay over here, and then there's a smaller relay over here, and I'm not sure if those are used to scale the incoming signal or not. The channels look identical. All three channels, the components look identical. I haven't sat down and exactly looked at every resistor value, but geometrically, and also looking at the colors here, they look pretty identical. So the signal, I actually tested to see if signals and trigger would come in, and they actually make it out of this maze to this part of the board unadulterated. But when I put, one thing that I noticed was that channel 1, you could scale the signal, and it seemed to come in unaffected, but later on when it leaves this board, it seemed to be scaled, whereas channel 2 was coming in unaffected, but it was kind of disappearing later on, and I'll show you where it was disappearing. But so yes, we definitely have a problem here. But next in line, we have these two ASICs that the signal passed through, and what else happens here is that if we look at the bottom of the board, there are three D2As over here, and these D2As, I'm guessing, are used to set the voltage, offset, and range. So basically the scaling of the conditioning of the input signal is done on this board. And your first suspicion might be that one of the D2As is bad, but what I think is happening is the D2A that conditions channel 2 is not getting the proper signals, so it is not properly scaling and or offsetting the signal coming in. So it's kind of a catch-22 situation, because the signal, when you hear those relays click, I think it's stepping through different sets of offset and attenuator settings. But since those signals aren't coming in properly in the first place, and of course they leave the analog board and go to the acquisition board, it's kind of a catch-22 situation, because the signal is never making it through, so that the outputting adjustment signals are incorrect, and not letting the signal come through. So obviously somewhere in the middle there something's going bad, but I have no idea what that may be. The last thing I found was that the signals, or I should say some sort of a signal, is coming out on these over here and goes on to the edge connector, which connects to the back plane, which in turn connects to the acquisition board and the processor board. So, but look at this thing. I was able to trace some signals, but without schematics. Oh, and another thing is that most of these chips that should be plain vanilla TTL chips are all house marked. I have no idea what those things do. So with those kind of obstacles in the way, and this was the last board that I could test live, and I'm not repeating that here because it wasn't very interesting just probing different parts of the board, but there is a signal, but I don't think that it's conditioned properly or that this board is doing something to the signal, so when it arrives at the acquisition board, it is no longer correct. So let's have a look at the remaining two boards, but remember, I can't even probe those, so we're just going to have a look at them. Next we have the acquisition board, which essentially the component side faces the underneath of the power supply, so completely unreachable without an extender. So this, the only real obvious things you see is there are 12 memory chips over here, so obviously it's working with a 12-bit resolution. 2 custom ASICs over here, and what I forgot to mention, the other 2 custom ASICs we had on the analog board, they're not soldered in. So I took them out, cleaned the edges, the contacts on them, and swapped them before putting them back in. And it made no difference whatsoever on the channel 2 error. So notice here that we do, let's see. Oh no, everything's still house marked on here. Not everything. There are actually, I actually ran across 2 or 3 chips that were that had just normal TTL designations on it. But other than that, you can see, well, we got a clock here that drives the acquisition part. I'm guessing that these, oh, I'm guessing that these custom chips, either these 2 or the ones on the analog board, are the actual A to D converters, because there's really nothing else here that looks like an A to D converter. But I did the same thing. Yeah, I swapped these 2 also, and it made no difference. And this has a much larger backplane connector because this is talking to both the analog board as well as the CPU board. But again, I can't poke around in it. I don't see anything obvious. I tested capacitors. I did not find anything that would suggest where our error might be coming from. And finally we come to the CPU board, which is sandwiched in between the acquisition and analog boards. And over here it's kind of refreshing because there are actually non-house marked parts on here. Not that it helps us much in our investigation, but at least I am not completely lost looking at this thing. To briefly look at it, it's also got the large type of connector to the backplane, and so I don't even know if this also talks to the analog board, or if it just or if all of the analog interface is on the acquisition board and then that digitizes everything and sends it over here. Or again, there's no block diagram, so I can't tell. It's got a connector for the front panel switches and another connector that goes to the display board over here. A nice collection of EPROMs. It's got a 6809 that is the main processor in here. That this is probably the main operating software. It's got some small static RAM down here. A TMS 9914, which is the HBIB or GPIB interface with the corresponding connector over here. The output that outputs over the BNC connector the test signal, the 2 kHz test signal, and that we had to connect the inputs to when we ran internal tests. And other than that, there's a 6845, which is a display chip. It's got another EPROM next to it that is soldered in, and this is the it's a standard Motorola display chip. This is probably the character generator definitions, and a couple of other things. There, as I said before, there are actually some non-house marked things here. Let's see if we can read those chips on top. What are those? Those are 54 series, 5K 4160 something. Those are static RAM chips actually over here. And other than that, we pan over a little bit. There's a crystal. I mean, if the crystal was dead, we wouldn't see anything on the screen, so no use in measuring that. A beeper. 3.9 volt battery, which is sitting at 3.7 volts. Oh, goody, a 74F374 over here. So we actually have some non-house marked chips over here. Actually, most of them on the CPU board are not house marked, so that's good. But here you have it. If I had an extender card, yeah, sure, I'd be measuring this and seeing what's happening and what's coming in and what's getting stuck, but no such luck. And you can probably guess what I'm getting at here. I really don't know what else to do with this. I guess if I hooked it up remotely, I looked through the remote commands and there really isn't anything in there that allows me to check things remotely. Oh, one thing I forgot to point out, that on the analog board of all things, there is an empty socket right over here that's labeled test. And it looks like it's a 24 pin, so it's probably a 2732 or something like that. And I did some more reading, and there is some test software available for this. But in order to run the test software, not only do you have to have the software, but you also need an external floppy drive to load the software into this device. So that's a no-go also. I did check capacitors on this board. So in short, I checked all of the obvious stuff. I tried to logically deduce where the error may be. But since I'm extremely limited in being able to make live measurements, and I'm lacking the test software and the drive and all of that, I think at this point I'm going to stop this analysis because it's not leading us anywhere. Now I can put things back together again, and maybe by some weird stroke of luck things will start working, even though I doubt that greatly. And the only thing remaining that I didn't show you is, there's of course our back plane. There's a lot of pins on that back plane. I actually took it out and put it back in and checked all of the pins if it looked like anything had a cold solder joint, if any of those pins were bent, but no success there either. Everything looked to be in perfect order. Okay, I put it all back together again and didn't make a difference. And yes, I heard all of you yelling at me when I called the dynamic RAM static RAMs on the CPU board. For the record, 4164s are dynamic RAMs. Thank you. And let's see, so I came back here. The only thing that I didn't do was reset the calibration and rerun it. Oh, first let's see if we can make this a little bit more visible since I left it open. Maybe that makes it a little bit easier to read. But anyway, there is a spot in the tests where you can go in and you get to the calibration menu, and what you're supposed to do is select the steps 7, 8, and 9, which erase the non-volatile RAM storage of all the calibrations that are in the machine, and then run 0 through 6 to repeat all of those calibrations. And I did that. I'm not repeating it because the calibration itself is somewhat lengthy, but after clearing, after defaulting everything, all the calibrations, and then running the internal test, everything basically failed. So then I ran the calibration, which took like 10 minutes total, I think. And when we went back to the tests and we ran the acquisition test, the acquisition trigger test, passing the clock, scale, interpolator, channel 1, fail channel 2, and pass the trigger. Nothing at all has changed, so it's not like anything got moved or put back into place. So this thing is still non-functional. So the only thing remaining at this point is, I mean, I could do a board. The only way I could do a board level isolation of where the problem is if I found someone who had an identical scope and who was willing to lend it to me and pull the boards out and do board replacement in here, and then it would tell me, hey, the acquisition board is bad or whatever. But that doesn't really help me either, because that would just tell me that you need a new analog board or acquisition board or whatever. So if I were really keen on getting this thing to work again, I would have to find one, an identical one that doesn't have a channel 2 error. From my tone, you probably heard that I'm not overly impressed by this instrument. Yes, it's an HP. Yes, it has really nice build quality, and yes, it has a horrible user interface. So I don't have a whole lot of interest in spending any more money or time on this, and we're just going to have to leave this thing as is. So interestingly enough, let's get back to the comment I made early on that this was sitting next to a LaCroix 9400, and if you haven't watched that one, the LaCroix 9400 worked, but channel 2 did not work. Now that one I had full schematics for, even though they were of limited usability because half the chips in the LaCroix were custom chips, and so you're basically limited to checking what goes in and what comes out, and that didn't reveal the error to me either. And even if it had, you're just, when you're doing that kind of troubleshooting, you're hoping that it's not one of the custom chips, which you're viewing as a black box that basically munches the signal. So I don't. It was a big coincidence that was sitting next to this, but I should have listened to the universe and left this guy right where he was. But I got a really neat $40 frequency counter now that I'm sure I'll be using often. Well, so what have we learned from all of this? If you're buying one of these things and you're in a rare circumstance where you can actually test it, spend a little more than 5 minutes and test it a little more. I mean, I didn't have any BNC cords and there were no function generators. I couldn't hook it up. But when you go to the main screen and you hit auto scale, you should at least get a trace in the middle of the grid somewhere. Which isn't true because nothing is hooked up now. Okay, I could have done anything without the... I couldn't have done anything because it's not even showing a zero reference trace when you have nothing hooked in. So there you have it. It's a nice scope. It's a shame that I can't get it to work, but it's really not the end of the world because it's not a very useful scope as far as I'm concerned. But it's an HP piece of equipment. So I hope you liked it and you enjoyed yourself. Leave me a comment and point out things that I supposedly glossed over. Don't tell me that I misidentified the RAM chips on the CPU board. Leave me a thumbs up and make sure to subscribe because promise, whatever it is I get next time, I'm gonna fix it. Later.